In this video, we'll be introducing some common limits at infinity that we're going to use to sort of shape and guide us in what we're going to be doing to evaluate future limits at infinity. So first and foremost, let's talk about the rational function. If we take the limit as x goes to either positive or negative infinity of 1 over x raised to a positive power. We'll say that p is a positive integer. And the reason we're going with an integer is because if p is not an integer, we might wind up with something nasty when it comes to that negative infinity. So essentially what we're saying is that x is going to get really, really, really big, which means that this denominator is going to get really, really, really big. When you have a really big denominator and a number for a numerator, that is going to approach 0. Now, you'll notice, once again, I'm saying that the limit is equal to 0, but really what we're saying is that the value is approaching 0, not necessarily equal to it. Second possibility is for exponentials. Now, when it comes to exponential functions, depending on whether you have a growth function or a decay function, you'll only have an asymptote on one side. So first one, for an exponential growth, if we consider the limit as x approaches negative infinity of a to the x, this will be equal to 0 provided that a is greater than 1. So if we had 2 to the x or e to the x or 10 to the x, in any of those situations as x goes to negative infinity, the y value would be approaching 0. Second possibility would be for a decay function. If we consider the limit as x goes to positive infinity for a decay function, this will be equal to 0. A decay function is defined as the base being between 0 and 1. Third possibility, and this does come up from time to time, is the arctangent function. The arctangent function has two different limits at infinity to be associated with it. The limit as x approaches positive infinity of the arctangent function is going to be equal to pi over 2. And the limit as x approaches negative infinity of the arctangent function is negative pi over 2. I think a little explanation for those last, well, actually an explanation for a lot of these would probably be a good idea. So for a rational function, rational functions tend to look like this, especially when they are reciprocal functions. Now, over on the opposite side, depending on whether p is even or odd, you could potentially see something like this, or you could also potentially see something like this. And in any case, as x is getting really, really big, the denominator is getting really, really big, and therefore the quantity is getting really, really small. For an exponential growth function, the general shape of an exponential growth function is the following, which is why as we go out farther and farther toward negative infinity, we are getting a smaller and smaller number. For a decay function, we'll see something similar. We'll just see the horizontal reflection of that. And we'll see that the y value is getting closer and closer to 0, the larger x gets. Now for the arctangent function, before we consider the arctangent function, I wanted to consider the tangent function. There's one specific part of the tangent function that I wanted to talk about, and that's the piece that is closest to 0. Now, we restrict the domain of the tangent function to ensure that this thing is 1 to 1. And the domain restriction that we use is that x has to be between negative pi over 2 and positive pi over 2. That's because when we consider the inverse function, you are essentially reflecting this graph about the line y equals x. Anything that used to be vertical is now horizontal. Anything that used to be horizontal is now vertical. So given that we had two different vertical asymptotes, the arctangent function is going to have two different horizontal asymptotes. Those two different horizontal asymptotes will correspond to the two vertical asymptotes that you see for the graph of the tangent function. This is why, as x approaches positive infinity, we see that the angle is approaching pi over 2. whereas when x is approaching negative infinity, the angle is approaching negative pi over 2. Again, approaching, not equal to, and that's okay.